So yeah, welcome. Thanks for choosing to spend the next 40 or so minutes here with me, talking about doing .NET in that other cloud. So that is me, and some means to get in touch with me. They will reappear towards the end of this session again. I spend my daytimes at a company called Doro as a software architect. People that know about Doro usually know that we make cell phones with actual buttons on them. We also have some smartphones, but what they have as a common denominator is that they are targeted towards the older people in our society. We also make some other sort of devices and services to improve the life of the elderly. But that is not what I'm going to talk about today. Even though there are connection points, we do build serverless stuff in AWS, but not so much with .NET. That is more of a private passion of mine. So I don't know if you noticed this. I figured when I was going to do this talk that it's always funnier to talk about something that sort of exists for real instead of just talking about something that could potentially exist, more of an academic thing. So I put together this little photo community that I sort of released. It didn't see much use, but it was fun to do anyway. It actually exists out there. It works, so feel free to use it if you want to. We will look at some code from that as we go along to see how that was built. I might demo it a little bit as well. So before we get started and dive into those things more concretely, I would like to spend a couple of minutes on an AWS terminology primer, just to introduce some concepts that are common in the AWS environments. Let's see here. Exactly, and we are talking about serverless, of course, all the way. And I hope that we are past this confusion with the name serverless, that there shouldn't be servers in there. And I think that it's just that we don't relate to the servers anymore, much like many of us have not really probably related to processors in quite some time when doing coding, but nobody came up with the idea to call it processor-less computing for that. But let's just leave that behind us and go into some AWS terminology. So the first term that we sort of meet when we start to use with AWS, when we start to use AWS environments, is the account. And an AWS account is sort of a top-level logical container. There is a little asterisk on top level here because you can actually group accounts into some sort of hierarchy for billing purposes. But from a security point of view, it's the outer security boundary that you deal with. You can think about an AWS account a little bit like a virtual data center that has a rather hard concrete wall around it, and either you're inside or you're outside, and there is very limited ways to get through that barrier. And we are talking about serverless, and the main serverless, I'll just see because this screen cuts finally. The main serverless compute offering in AWS is what is called AWS Lambda. And Lambda is, well, a means to deploy code to be executed. You do that by choosing a specific runtime on which you want to execute this code. So you don't talk about servers or any characteristics about that. You say that I want a Python runtime or a Node.js runtime of a certain version or a .NET Core runtime, and you deploy your code. It lives inside the account. So when you have deployed Lambda, it's sort of not invocable from the outside. It's an internal resource in that account. So for that purpose, it needs something to trigger it. A Lambda by itself is a not very interesting entity. And in my case, since I build a website, the trigger is an API gateway. An API gateway is, well, a means to publish HTTP or WebSocket endpoints, essentially, and then you can sort of have them act as a front door to other resources that live within your account, for instance, a Lambda. Also, since I host things, I serve photos that people can upload. I have some means to host that, and that is, in the case of AWS, something called S3, which is a simple storage service. That is actually literally what S3 means. It's 3 S's. So essentially, you create buckets, and you can put objects and files into those buckets and have them stored and expose them to the internet there. And then finally, for data storage, I use something called DynamoDB, which is, to quote Amazon themselves, is a key value and document database that delivers single-digit millisecond performance at any scale. That is a pretty bold statement. And you can achieve that if you design it well. I met with a solution architect from AWS a while ago, and he said that when they were designing DynamoDB, one of the driving design requirements was to create a database that was virtually limitless in its scale capability. So, and this is no NoSQL database, so you can, and it's even encouraged that you mix several types of records in the same table. They can have different set of attributes. They can look quite different, each of them. And it's a database that is really great for predictable data access patterns. So if you have a website or an app where you know the user flow, that you know that they will go to this page being served the latest bunch of photos, they will click a photo and you retrieve that photo and likes and comments based on a photo ID, and you have that kind of predictable user path, this will perform really well if you design it for it. It is not great for unpredictable data access patterns, of course. So if you have an application or a website where users are to sort of dynamically query your data store, this is not the data store for you. So it's important to think about that when you design your things. Another thing to know is that access is controlled by permissions in the system, which is, we will look at permissions in a moment, and it's a very, very elegant solution to security, because since this is a serverless database, you don't have a server that you run, you don't log into a server or deploy things into a server, but into the cloud. And that means that since you have the permission system controlling access, there is no secret to store. There is no connection string. So you can be open, you can actually check the permission rules into your Git repository and publish that, because nobody can do anything with that information, really. Which leads us to identity and permissions. So the main suspect in this area is, of course, the user. The user is exactly what it sounds like. It's an identity, and it's identity that represents a person. So when I go into my AWS account, I have a username and password, I log on, and I come into the system represented as a user. Then there is something called a role. And the role is also an identity, but it's not an identity that represents a person. But it is an identity that can be assumed by a user or by a service. So anything that executes inside an AWS account will execute in the context of a role. And that role can have a set of permissions attached to it. This is an example of such a permission. And a permission will always have these three elements. It will have an effect that can be either allow or deny. And by default, everything is denied. So unless you have a permission explicitly granting allow to a specific action, it is denied. If you look at the flow chart on how AWS determines whether or not to allow a certain thing to be carried out, I think there are like 5 or 6 exit points leading to deny, and there is one way through that will actually allow you to carry out the action. And if you have conflicting permissions, you set up one allow and one deny for the same set of actions, it will be denied. So in this case, what we can see here is that we allow the permission to execute those 3 actions in S3, get object, delete object, put object, on those 2 specific S3 buckets. And you can put in wildcards so you could say S3.star, for instance, that would allow any S3 access in these buckets. You could say ARN AWS S3 star, which would allow for all buckets and so on. So you can sort of decide on how granular you want to be. So this is how you design permissions. And then finally, there is an entity called a policy. And a policy is essentially just a document where you can collect a set of permissions and stick a name on it. And then you can take that policy and associate it with users or roles. So we have users, roles, permissions, and policies. And they relate to each other like this, that you can connect a permission to a user or to a role. And then you can have a user assume that role. Or you can put a permission on a policy and then put that policy on either a user or a role. And also, we know that a user can assume a role. So there are essentially 4 paths between permission and user in this case. There would be no difference in effect what happens here. The permission set in the permission will be granted or denied to the user based on the contents. It's just different ways of managing these permissions. And whichever is better, it really is up to you and your process and what fits your bill. So enough of the slides for a moment. And let's look at how to actually do some things. Now I need to switch screens and do a little bit of magic here. I will see if I can manage this. That seems to work. So what I will do now is that I will create a .NET Core ASP.NET MVC website from scratch and put it out in a Lambda and publish it to the internet, essentially. So, as I said before, when we publish a Lambda, we choose a runtime. So we need a .NET Core runtime, and now we are not in Microsoft land, but in Amazon land, and they sort of lag behind a little bit. So the .NET Core runtime that is offered out of the box right now is .NET Core 2.1. The reason for that is that Amazon supports the long-term support releases of .NET Core, and the latest such release was 2.1. The next one that will come up is 3.1, which is due for December, I think. So right now, if you want to use the runtimes offered out of the box, it's 2.1. You can package your own runtime and actually deploy on that, but that is not what I'm going into today. That is not very complicated to do if you really want to run things today on 3.0, for instance. So what I want to do is to create a .NET Core MVC 2.1 application. So first I want to sort of lock down my workspace to use that SDK. So to do that, I want to create a new global JSON file. And I don't have the fastest PC on the planet. So here we get a new global JSON file, which is then saying that we should use 3.0. Can everybody in the back see the code, by the way? Or should I go larger? No, it's okay. So on this machine, .NET list SDKs, I have, as we can see, 2.1, 802, and 3.0.100. So I just take this here. Let's see if I can get that, and I put that up here, there. So now my workspace is locked to 2.1. So now if I say .NET new MVC, it will create an MVC boilerplate project for .NET Core 2.1, which we have there. So we can just run it to see that everything is okay. One of these days. There we go. And there we go. So we have a standard out-of-the-box MVC site. So the next thing we want to do, apart from closing it down, is to add the things that we need to add for this to integrate into AWS Lambda. And that is 3 NuGet packages and 1 class, which will act as a bootstrapper into our application. So since my memory is not really super, I will actually do like this. So we add a new package. So we have a Lambda, add package, sorry. There we go. So we add the Lambda ASP.NET Core server, which is some integration glue there. And we add this one. I can actually do like this. That was wrong. And I want this one. There. There you go. So this means that we have those 3 NuGet packages in our project. Second thing we want to do is to create a new file. I will call it Lambda entry point. The name is not really important. You just need to remember it for a bit later. So we add this code. And what this code does, if we like this here, is essentially that it acts as an entry point. So the Lambda runtime will inject a website builder, and we just tell that to use our regular startup class for bootstrapping. So from this perspective, it's the same. We use the same startup bootstrapper. When we are here, now we want to have a zip file, essentially, that we are going to upload into AWS Lambda. And the easiest way to do that is to use the Amazon Lambda.net tool, which you can install. There will be commands shown how to do that later. That essentially installs some commands into .NET. So you can say, I will actually do like this so we get it up on the screen a bit. .NET Lambda package. And then you tell it to make a release build, and that it's a .NET Core app 2.1 framework thing. That will essentially run a .NET publish and zip the contents into a zip file. There we are. So that zip file will now live in here. So I copy that path, bring that with me when I go into the console. And then I just switch over to my demo account and go into Lambda and create a new function. We author it from scratch. We call it Øredev 2019 demo Lambda. It's not a node, it's a .NET Core 2.1. As I said, anything needs to execute as a role. We can now have the system just create a basic role for us, which have the minimum set of requirements needed to execute Lambda at all, which essentially allows it to log things. So I create the function as it is. And sometimes it's a bit faster. There we go. So here is the function. So I upload my zip file, which I then have there. And then I want to tell the system that when this Lambda is executed, what function in my code should you execute? And I do that by pointing out the assembly, AWS Lambda, my .NET Lambda, sorry. .NET Lambda, and then the namespace, and the class name, Lambda entry point, and then a method name which is in this class, which is called function handler async. Then you can configure like timeouts and amount of memory and all sorts of things, but I will just leave it as it is for now. So I save this. And as we can see here, we now have our Lambda. It has access to CloudWatch logs, so we can emit some logs. There is no trigger connected to this Lambda, so there is nothing in the system that can actually make this execute in any way. We can test it though. So we'll make a quick test. So I will set up a test event. This will be published, as I said, through an API gateway. Let's see here if I can get to that. So we make a copy of this. And I just need to remove some fluff from this so that it actually fits something that our website knows about. So there's a couple of things that I need to remove. There, replace all. It's a get command. Get, replace all. And then I think there is something in the bottom here that I want to get. There, exactly. There. So let's give this a name, API get root, create this test event, and now we can test this function, and if all is good, we will get a green screen. We can see here that we got an HTTP 200 response, and down here we have the HTML coming out of our website. So now it's actually deployed and running inside AWS Lambda, but we still have no means to actually access this site from the outside. So that is our next step, which is then done in the API gateway. So now I forgot to remove this one from my previous attempt, so I will just create a new one. So we call this Øredev 2019 Lambda demo API 2, just to be safe. And there we are. And we set up a get method that when you get the root, you should invoke a Lambda function using proxy integration, and our Lambda is called, wow, which one was it now? Oh, my memory serves me badly. Let's go here and see. Demo Lambda, good. So demo Lambda is the one that we deployed now. Save. And we need to give some permissions to gateway to actually invoke the Lambda. So now we have what we need to publish the root on the internet. But we want to publish the whole site, right? So we need to add another resource, which is a proxy resource that will essentially funnel anything that is not the root. It will just take the path, pass that down to our Lambda, and the routing happens there. So we say that we create such a resource. It should be going to the same Lambda, and we save it. and now our API is ready. So now we need to deploy it. I did? Of course I did. Thank you. Demo Lambda there, and Demo Lambda. I picked the right one, I think. But thanks, anyway. Live coding is always not so simple. So we deploy the API into a stage. You can have like prod and dev stages and whatever you like. I just call this prod now because we deploy always directly into prod, right? And there we are. It's published on the internet. So we can see here, we can just click around to see that it actually works, and it seems to work. So that's nice. So those steps, which are not that many really, create an MVC website, add a couple of NuGet packages, add the entry point, the Lambda, and the API gateway, and that is all that is needed really. So with that, let's go back to, let's see here if I can get this all right. There. No. There. So I will look a little bit into the stack for this web thing that I did. I can actually just briefly show it so you know what we're talking about. So I will add a new window. I will pop that over there, and we go to my... So it's this website here. It's amazing. It's a small photo community. So essentially what you can do, now I need to look at that screen, that will be weird. You can click around here at the pictures and see what people write about them. You can click on a user and there will be that person's pictures, and there are likes and comments, and well, a pretty basic photo community essentially, and you can sign in using social network profiles and stuff like that. So that is what it does, and it has some scoring mechanism to sort of rate the most popular pictures on the front page and stuff like that. So that is the website, the code that I will be looking into a little bit. And I will see if this works. Yes, it does. Good. So now there was a lot of like manual labor here. I clicked around in the web UI for AWS to deploy and do stuff like that, and that is not how we want to do things, right? We want to have automated deployments and scripted infrastructure and all that. So the means to do that in AWS is something called CloudFormation, which is a text-based templates for infrastructure that you can write in either YAML or JSON. That describes the infrastructure that you need to run your stuff, essentially. This is an example from this one. It's the CloudFormation template for the S3 bucket that hosts the pictures that are served to the internet. So what we can see here is that this is a resource. I give it a name. I tell it that it's this type here, it's an S3 bucket, and then there is a bunch of properties that are depending on which kind of resource I'm setting up. In this case, I give it a name, and I set up some coarse rules because I'm serving the photos not through the MVC website, but on a static website that is through a content delivery network, so it has a different domain name. It's like static dot whatever instead of www. So I need to set up a coarse rules to allow the website to actually fetch those resources. So that is how that looks in CloudFormation speak. And this is the whole website system as a CloudFormation template. And that can look a bit daunting. It's lots of stuff on here. I think I counted that there are 32 items on this chart here. Luckily, about half of them is created automatically for me. So I have configured approximately half of these things, which is the Lambda functions, the buckets, some policies for access for the buckets and stuff like that. We will look into that. And I use actually a third-party tool called the serverless framework that you might be familiar with. It's an open source project that actually takes care of a lot of the heavy lifting when it comes to deploying these things. Instead of writing all these CloudFormation templates manually, it creates lots of them on the fly that you need. So somewhat simplified, this is what the stack looks like. The website is served through an API gateway that is triggering Lambda, which is fetching its data from a DynamoDB database. Then the static content, so all the photos are served through something called CloudFront, which is an edge cache content delivery network service in AWS, which is fetching the stuff from an S3 bucket that we saw the configuration for here. And then when you upload photos from the website, you actually upload them directly into an S3 bucket, and the event of an item added there will trigger another Lambda, which will pick up the photo, scale it down to web sizes, and put it over into this hosting bucket, and also update the DynamoDB database with photo information. So I said before that the single-digit speed from DynamoDB comes from designing the database well. Now, I don't claim to be a world-class DynamoDB database table designer. I did spend some time thinking about this, and I can say that after having worked with a couple of decades with designing, relational SQL database systems, it's pretty hard. It's many of the things that you know as good design in relational databases is bad design in this world and the other way around. So data duplication is a good thing, for instance, and so it takes a while to get used to how to think about it. But the key to this is the indexes. So what we can see here, the green and the blue, I hope that we have no color blindness here, but this left one is green and this one is blue. This here is known as a partition key. It's not a primary key, it's a partition key. And we can actually see here that we have several items with the same ID in that field. The other one here is known as a sort key. So what DynamoDB does with this index information is that it will create partitions of data where it will store the items together. The items having the same partition key will physically be located next to each other, and they will be sorted according to this. The combination of these two needs to be unique. And with this index here, if we look at the data on the screen, we can, for instance, make a search where the partition key equals a certain string. That will give us all the things from this table sharing that same partition key. So it will be a mix of, of photos, of likes on photos, comments on photos. So that will essentially give us everything that is related to that photo. The photo itself, likes and comments. What we can do is that we add that sort key should start with the string like. We can see here that the sort key is like pipe user. So this is a record saying that this user liked this photo. So by adding the sort key starts with like, we get all the likes for this photo. If we add this one, comment pipe user ID, we get all the comments that that specific user has posted on this photo. So this same index actually allows us to perform quite a few different searches depending on how we have constructed our keys. It's known as composite keys. So if you think about what you want to query from your database, and you can actually construct your keys in a way so you can post many different queries on the same index. Now in my case, I have a secondary index as well, where this GSI1 partition key is the partition key, and this is the sort key. So with this index on the same table, I can query for, give me everything that this user has done. All the photos, comments, and likes and stuff for that user. Or I can say, sort key starts with photo. Give me all the photos that this user has uploaded. And so on. So with those two indexes, I have a quite wide range of data access patterns that I support. So let's look a little bit at the website itself. And it's built essentially like this. I would say it's a fairly classic pattern to build stuff. So I have the MVC controllers on top. They will consume things from, well, service interfaces that I use dependency injection to just shoot in the correct service. They will pick up from database repositories, which are then DynamoDB specific. And then I have just encapsulated some of the DynamoDB nitty-gritty into a sort of core thing there. So with that, let's look at some code. So I should do like this and like that. And we can, am I on the right screen now? Yes, I am. There we go. And we can actually ditch this one and that one. And here we are. So let's start with the templating, how we deploy things. So here is the template. It's pretty long, as you can see. And it's nothing that you start off needing to build all this. It's sort of growing as you move along with your project. But essentially, what I have here is that we set up a header here where we just say that, okay, I'm going to deploy an AWS service. Serverless supports Azure and some other stuff as well. I tell it what runtime to use, the API stage to use. I set up some for logging that I should just keep the last 5 days of log so it doesn't just grow. A bit about tracing and stuff like that. So all these things will actually lead to some of those things ending up on the CloudFormation template. Here is the role. So here I define what permissions will my lambdas have. So in my case here, we can see here is the permission that I showed on a slide before, allowing this lambda to get, delete, and put objects in those S3 buckets. I need to allow it to do some things on DynamoDB, so it needs to have access to these commands. And I here have a little constructor. We don't need to dive into detail, but essentially this will point out the table name that I use. I also explicitly need to grant access for the indexes. So if I don't do that, I can't query indexes. I can only query the main index for the table, but no secondary indexes. So that is an explicit command. That bites me the first time, every time. I don't understand why it doesn't work, and then I realize I forgot to grant access to the indexes. And some other things that it needs permission to. So here I control essentially what the lambda can do. And anything that is not here, it's forbidden. If you try to do it in your code, it will just blow up on you with an access denied permission exception. Then I have the function specification. So this is the lambda for the website itself. So I just say that here is the entry point, the handler that I was writing manually with the function handler async. 10-second timeout, 768 megabytes of memory, and here is the zip file. And here is the API gateway configuration. So the whole thing that I did in API gateway is those 5 lines, 6 lines of codes here. And then I have a bunch of environment variables. So I built this website very dynamically. So I inject the name of the DynamoDB table and all sorts of things that it needs to run from the outside. Then there is a lambda to make the web images, which is then triggered by an S3 event in this bucket, and the scoring working and such. And here is the rest of my resources. So here is the DynamoDB table and everything. This code will be on GitHub it is already on GitHub actually. So if you want to, you can just download it and dive through this in your own pace. I figure we should follow the call path for a call from the top down to the bottom. So I selected the API call that fetches the command. So when you go onto a photo page, JavaScript will call this API endpoint to load the comments for that photo onto the page. So it will have a photo ID coming in here. I have a feedback service from which I pull photo comments using this ID, which will essentially just pipe this to the repository. And now we are down in DynamoDB land. So we set up a query request from a table. And one thing that astonished me when I started working with DynamoDB is that the guys who wrote this API, they really love dictionaries. There is dictionaries for everything. So anything that you need to put in or get out comes as a dictionary of some form. So here we have a dictionary of string and condition. String is then the attribute name, the column name. And then there is a condition, which is string equals something, string begins with something, number equals something, and so on. So here I set up that the partition key should equal this photo ID, and the sort key should begin with the word comment. So as I showed in the slides, I will pull out all the comments for this photo ID. And then I run the query in DynamoDB, and since the return is a dictionary of string and attributes values, and I want to actually use C# classes for this, I have built a specific kind of mapper that will take this input here. So here is the response from the database, dictionary of string and attribute value, and then I just unpack that and put that into a class and return that instead. So I've sort of tried to encapsulate the DynamoDB ugliness in one place. And the rest of the site is essentially rinse repeat on that pattern. So let's do like that and go back here and here and here. That works, and that also works. No, you don't see anything, right? There you are. And this there. Now we are back. So to sum it up, because there is really not more magic to it than that, these are the steps required essentially. Set up your environment, set up your project, build for deployment, that is the Lambda package command, and deploy it. And setting up the environment is essentially these steps. .NET SDK 2.1 for now. But you can, as I mentioned, package your own runtime in something known as Lambda layers. It's not very complicated. Lots of information online on how to do that. Download and install the Lambda tools. You can install them directly from the command line like that. Serverless framework is a Node.js thing, so you need Node.js to do that. In this particular site, I also use TypeScript for the JavaScript, the client side. So you need to install TypeScript as well. Fix the project is locking to 2.1 with a global JSON file. Add these dependencies and the entry point. Build for deployment, .NET Lambda package with the configuration. If you are not running it in the project folder, you need to point out where the project is, which you would do probably in a build script. And put it out in Lambda and connect it to a suitable trigger. So in my case, when you look through the code there, you will find that there are 3 different triggers. It's the API gateway for the site, it's the S3 bucket for the uploads, and there is a timer trigger in CloudWatch, which every some minutes triggers the scoring calculator that will just go through and see if it needs to adjust the score of some pictures. And that's it, really. Thank you. And I leave this here, some links to good resources. I can especially, if you want to dive into DynamoDB, I can recommend warmly this here, this session here from reInvent last year. When I watched it the first time, I had to stop sometimes and just go back and say, what the hell did he say now? Is that really true? And it's kind of mind-bending if you come from a deep SQL relational point of view. But it's very informative. Any questions? Either if you want to take them now if you're brave, or I will be around for the rest of the conference, so you can just catch me and you are brave. Yeah, I mean, the question is if I had to do any limitations in my code to have this function. And I have not done any specific things with my code. There are limitations. It's good that you bring that up. I'm not sure exactly how many minutes you have. It might be around 15 minutes here as well. I usually try to keep the execution time really short, of course. One limit to be aware of if you're building like massive systems. So this works well if you have a reasonably sized user base, because there is a limit that you cannot have in an AWS account more than 1,000 lambdas executing at any given time. So, and that is really the execution time we're talking about. The execution times on this site, when you look at it, is typically around 50 milliseconds or so. It's rather short. But if you have like massive amounts of users, you might actually run into issues with that you need to think about in some way. I should also mention something about cost, because that is also interesting. How much would it cost to host a solution like this? And I don't have a lot of traffic on this, so this is for free. Essentially, but I did try to calculate like, well, what should we say, a reasonable usage pattern and scale it up to 10,000 users, and that would give that this solution would cost around $100 a month to host with 10,000 users and with a reasonable action rate on it.